In this lesson, you're going to be learning about chemical names and formulas, and we're also going to review some things from the periodic table unit. So I'm going to start off with a periodic table review. In the last unit, we learned about atomic structure and how to interpret things from the periodic table, but just a quick reminder about that. The first part of the proton, or on our periodic table, we have different parts of it. So remember that this number right here, this whole number here, is our atomic number. And our atomic number is equal to our protons. And remember that protons are found in the nucleus and they have a positive charge. So the identifying part of an atom is the protons. So the number of protons is equal to our atomic number. And again, on our periodic table, that is the whole number in the box with the element name and symbol. So the symbol here is just the single capital letter or the capital letter with a lowercase letter next to it. In this case, oxygen, it only has the capital letter. So this is our symbol. The word is the name. And then the number that has the decimal on it is our average mass. Remember that that's the average mass of all the isotopes of that element. Outside the nucleus, we have our electrons. So these are outside the nucleus. And they have a negative charge. So in a neutral atom, and most atoms are neutral, which means there's no electrical charge. Our positive parts have to equal our negative parts. So that means that we have our positive parts are our protons, and our negative parts are our electrons. In a neutral atom, our protons have to equal our electrons. So in our oxygen atom here, because the atomic number is 8, that means we have 8 protons. And because our positive parts have to equal our negative parts, if we have 8 protons, that means we also have 8 electrons. So we're going to practice this. And you're going to use the periodic table to write the element symbol and protons and electrons in a neutral atom of all of these elements. So to review your answers and to check your answers, copper has a symbol of Cu, zinc has a symbol of Zn, oxygen has a symbol of O, silver has a symbol of Ag, nitrogen has a symbol of N, magnesium has a symbol of Mg, iron has a symbol of Fe, aluminum has a symbol of Al, potassium has a symbol of K, sulfur has a symbol of S, gold has a symbol of Au, carbon has a symbol of C, chlorine has a symbol of Cl, hydrogen has a symbol of H, iodine has a symbol of I, calcium has a symbol of Ca, sodium has a symbol of Na, and lead has a symbol of Pb. So to find the number of protons and electrons that we have in each of these atoms, you look up the symbol on the periodic table and you find the whole number. So in copper, you have 29. It's element 29. So that means there's 29 protons and 29 electrons. Zinc is element 30. So that means we have 30 protons and 30 electrons. Oxygen is element 8. So that means we have 8 protons and 8 electrons. Silver is element 47. So that means we have 47 protons and 47 electrons. Nitrogen is element 7. So we have 7 protons and 7 electrons. Magnesium is element 12. So we have 12 protons and 12 electrons. Iron is element 26. So that means we have 26 protons, 26 electrons. Aluminum is element 13. So that means we have 13 protons and 13 electrons. Potassium is element 19. So we have 19 protons and 19 electrons. Sulfur is element 16. So we have 16 protons and 16 electrons. Gold is element 79. So that means we have 79 protons and 79 electrons. Carbon is element 6. So we have 6 protons and 6 electrons. Chlorine is element 17, so we have 17 protons and 17 electrons. Hydrogen is element 1, so we have 1 proton and 1 electron. Iodine is element 53, so that means we have 53 protons and 53 electrons. Calcium is element 20, so that means we have 20 protons and 20 electrons. Sodium is element 11, so that means we have 11 protons and 11 electrons. Lead is element 82, so that means we have 82 protons and 82 electrons. Please make sure that you check your work that you've written down in your notebooks before moving on. So elements can combine to form compounds. A compound results when 2 or more different elements bond. So a compound is 2 or more elements bonded. Two or more elements bonded. Some compounds are made of positive and negative ions that are bound by their mutual attraction. What does that mean? That means that ions that are oppositely charged are attracted to each other. So ionic compounds are made of ions that are oppositely charged, and because those ions are oppositely charged, they're attracted to each other. So an ion is an atom that has lost or gained electrons, and therefore is charged because its protons and electrons no longer balance and cancel each other. So how do these form? They can either gain electrons or they can lose electrons. So if they lose electrons, they now have more positives than negatives, So that means they are positively charged. And they're called a cation. And metals do this. Or they can gain electrons. If they gain electrons, they now have more negative parts than positive parts, so they are negatively charged. And they're called anions. And this happens to our nonmetals. Okay. So a quick reminder about how to find the ions and what ions things will form on the periodic table. Our first column of our alkali metals will form a +1 ion. Our second column of our alkaline earth metals will form a +2 column. Aluminum here will form a +3. These generally don't form ions because they can either gain or lose 4, and so they generally don't form ions. Our column 15 will form a -3 ion. Our oxygen family will form a -2 ion. Our halogens will form a -1, and our noble gases do not form ions. And these are written on the periodic table that you were given in class, but just a quick reminder of how it works. +1 for our first column, +2 for our second column. Aluminum has a +3. Column 15 has a -3. Column 16 has a -2. Column 17 forms a -1 charge. So what that means is an atom of sodium has lost an electron to form a +1. This column will lose 2 electrons. Aluminum will lose 3 electrons. On the opposite side, these will gain 3 electrons, these will gain 2 electrons, and these will gain 1 to give them the charge. So if we look at compounds that are made from alkali metals and halogens, remember that our alkali metals have a +1 charge, and our halogens have a -1 charge. They're right there and there on our periodic table. So the chemical formula for the compound potassium bromine, between potassium and bromine, is KBr. So if we look at the purple shape as a potassium ion, it's going to be K+, and we look at the gray shape as a negative ion, it's going to be Br-. Each one, so we have the charge is of +1 and -1. So +1 and -1. And that forms KBr. So between potassium and bromine, this is going to equal KBr. And you'll notice that you have 1 and 1 of them. So I want you to list 4 other compounds that are made from elements in group 1 combining with elements from group 17. So pick an element from group 1 and combine it with an element from group 17, and do that with 4 different combinations. The next thing that we need to consider is elements made from the alkaline earth metals and elements of column 16. So, for example, magnesium and oxygen. Magnesium, being part of the alkaline earth metals, forms a +2 ion. So again, our purples are going to be here, and this is going to be Mg +2. And oxygen forms an oxide ion with a -2 charge. So again, oxygen is in column 16, so it has a -2 charge. So if we look here, it's going to be a -2 charge. And again, these match up to combine. And so when you combine them, you get a chemical formula of MgO, because you need 1 magnesium and 1 oxygen. So I want you to list 4 other elements that are created from elements in group 2 and combining with elements in group 16. So you're going to pick an element from group 2 and you're going to combine it with an element from group 16, and you're going to find 4 different combinations other than magnesium and oxygen. So the charges of the positive ions in a compound must equal the charges of the negative ions in that compound. If the values of the charge on a positive ion and a negative ion are the same, the formula of the resulting compound is simply the chemical symbols of each element, which is what we saw in our previous example. When the 2 charges were equal with the alkali metals and the halogens, we just took the symbols and stuck them together. Same with the alkaline earth metals and the group 16, we just stuck them together. But what happens if they're not the same? So for example, NaNCl, Na is an alkaline metal, so it forms a +1 charge. Chlorine is a halogen, it has a -1 charge. Because they are the same charge, you can just stick them together, write the symbols together. Another example, while the charges are different, if we look at find magnesium on our periodic table, go to the top of it, we find that it's +2. Oxygen, we go to the top, find that it's -2. These are the same charges, so again, we just write our symbols and stick them together. But what happens when they're not the same? So if the values of the charge on a positive ion and a negative ion are not the same, then we use subscripts to balance those charges. So for example, aluminum and iodine. If we find aluminum on our periodic table, it's right here, and we said that that was a +3. Iodine is here, or here, and so that's part of our halogens, so it's -1. So if this is our +3 for aluminum, and this is our -1 for our iodine, you see that we don't have the charges are not balanced right now. So we need to make them balanced, make them equal, so we don't have any jagged edges on here. So to do that, we would need another iodine. If I add one more iodine here, the iodine shape would be the same here. If I add one more iodine, we still have one more jagged edge, so I need to add another iodine here, and then I don't have any jagged edges here, so I use 3 iodines, 1 aluminum, so then my formula is Al, and I only have one of them, so there's no subscript, and then I, but I have 3 of them, so I need to say that I have 3 iodines. Another example, if I have calcium and chlorine, calcium is here, so it is a +2 charge. Chlorine, also one of our halogens, is -1. So if I do a quick drawing, I'm going to have 2 jagged edges for my calcium, and my chlorine only has the 1 indent because it only has a charge of 1. So there's my iodine, or my chlorine. And I still have a jagged edge, so I need 1 more of these to make smooth edges. So that means I need 1 calcium, and I use 2 chlorines, so I put a subscript of 2 on the chlorine. So the subscript is just a little number that you're writing after an element to indicate that there's more than 1. So small number written after the element to show more than 1 is needed. So you're going to go ahead and practice You're going to write the chemical formula and the name for the compound formed when the following pairs of elements are combined. So for calcium and oxygen, we know that calcium is +2, oxygen is -2. Our charges are the same, so we're just going to take our symbols and smush them together. So calcium has a symbol of Ca, oxygen has a symbol of O, so we are just smushing them together. Aluminum and fluorine. Aluminum has a +3, fluorine has a -1, so they're not the same in this case. So then we have to think back to our edges, and so my awful drawing, pretend that's there. Okay, so aluminum has 3 pointy parts, and then fluorine would have, it is a -1, so it only has 1 indent. So I need to fill in 2 more indents, which means I need 3 of them. So my formula would be AlF3. Boron and oxygen. Boron is part of the aluminum family, so it is +3. Oxygen is going to be -2. So this one gets a little trickier. So we're going to have our 3 pointy parts again for boron, and this one has 2 indents. So we need, now if I add another one, I have an extra indent for the oxygen. So I need another boron, which has 3 pointy parts. So there's 1 that's taken up, and then this would have 2 extra, so then I would cover that up again. So then I have 2 of the borons and 3 of the oxygens, so it would be B2O3. Strontium and nitrogen is going to be similar to, it's a +2 and a -3. So again, we got to worry about the idea of balancing the charges. So strontium is going to have 2 pointy parts because it has +2. Nitrogen is going to have 3 indents. So if I match it up, I need 1 more indent here. And we don't have smooth edges again, so we need to add another one. But again, there's 2 pointy parts to it, so it doesn't match up. I've got 2 more indents to draw, and then we can cover it up with 1 more. So we have 3 strontiums and 2 nitrogens, so it's Sr3N2. And then barium and selenium. Barium has a +2 charge. Selenium has a -2 charge. So if we partner these up, they're the same charge. So again, when they're the same charge, we just write the element symbols and smush them together. So barium is Ba, selenium is Se, and there's my formula. Some compounds, like baking soda and sodium hydrogen carbonate, incorporate polyatomic ions. A polyatomic ion is an ion made of several elements joined together. So in this case of the Na sodium hydrogen carbonate, NaHCO3, Na is one ion and HCO3 is another ion. And HCO3 has 1, so we draw our Na here, and it has, we know that sodium has a +1 charge because it's in that column of our periodic table, and we only have 1 of them, so we only have 1 HCO3, so we know that it has a -1 charge. So HCO3 minus. So these just stick together as one thing, and you still count them as one piece based upon the charge, and the amount that you need. So you treat it the same, you're just writing more symbols for your anion. Okay, so now you're going to write the chemical formula. We're going to use that information to write the chemical formula for each compound below. So on your polyatomic ions, when you're given the symbol, this is your charge here. So you know how many either indents or bumps to put onto the polyatomic ion. So potassium, one of our alkali metals, has a +1 charge. Nitrate has a -1 charge. And again, because the charges are the same, we write the symbols and smush them together. So KNO3. And you know that nitrate is NO3 because you're told that it's NO3, and you don't write the charges when you're writing the compound name or writing the compound formula. Barium sulfate. Barium has a +2 charge. Sulfate, looking over here, has a -2 charge. They're the same charge, so again, we just smush them together. Barium has a symbol of Ba. Sulfate has a symbol of SO4. And we drop the charge when we write it in the formula. So it's BaSO4. Potassium sulfate. Potassium, one of our alkali metals, still up here, has a charge of +1. Sulfate, we know from the previous problem, has a charge of -2. So we have, if we look at potassium, it's going to have 1 bump because it has a +1 charge. Sulfate has a -2 charge, so it's going to have 2 indents. And so we have a jagged edge, so we need 1 more potassium to even out the edges. So that means we need 2 potassiums, so we write K2, and 1 sulfate, so we just write the formula for the sulfate, which is SO4. Sodium acetate. Sodium is one of our alkali metals, so it's a +1 charge. Acetate has a -1 charge because you're told that right there. And so sodium has a symbol of Na. Acetate is the C2H3O2 because these are the same charge. You just write the symbols and smush them together. And our last thing of practice is to go the opposite way and now write the name for each of the compounds below. So the polyatomic ions can be found on the back of your periodic table. There's a list of them. And you will be given these for quizzes and tests, so you don't have to memorize them. So list the name for each of the compounds below. So you're told that ammonium is NH4. So all you're going to do is write the name of each ion and smush those together to find it. The amount of them doesn't matter. You're just writing the name. So you're told here that NH4 is ammonium. So it's ammonium. And then the anion is going to be sulfate. So you have ammonium sulfate. Here, the first part is aluminum. So we just write aluminum. And you're looking at the second ion here, and so because it's a polyatomic, because there's more than one capital letter, you know that it's a polyatomic. You're going to look at the list of polyatomic ions that are found on the back of your periodic table. So CO3 is carbonate. You look that up and you find that it's carbonate. So this is aluminum carbonate. The last one, Li, you look it up, it's lithium. And HCO3 has 2 names. If you look them up, it is either hydrogen carbonate or bicarbonate, and I like bicarbonate better. So I'm going to write down lithium bicarbonate. You could also have written down lithium hydrogen carbonate.